We're going to start with basic derivative rules. So that long limit definition is obviously not something that you want to repeat over and over again, and there has to be a better way. There has to be shorter ways. And what you'll see is there are a lot of derivative shortcut rules that we'll learn throughout this chapter, and even in future chapters, we'll kind of keep adding to our basic knowledge. So I'm going to kind of number them as we go, just because there are so many that we'll learn over the course of the coming weeks. So our first basic rule is called the constant rule. And what the constant rule says is that if you derive a constant, so I'm just going to use this notation, you get 0, which should make sense because think about what a constant function looks like. If you have a constant function like y equals 5, if I were to ask you what y equals 5 looks like, it is a horizontal line. And what we know about a horizontal line is a horizontal line always has a 0 slope. So any constant that you have will derive to give you 0. So our second rule is called the power rule, and the power rule is the big one. And when I say the big one, I don't mean in like size or length, I mean in frequency. You're going to use this power rule over and over and over and over again throughout the entire course. So hopefully it becomes second nature pretty quick. And what the power rule says is you are deriving x to any power. And that power, that n value, can be any integer. It can be it can even be a fraction. It's really any real number that you're working with would be something that we can derive using the power rule. And the way the power rule works is you bring the power to the front, write it as a coefficient, and then you take it times the variable to a power 1 less. So you're going to hear me say power out front, power 1 less, like over and over and over again. And hopefully it just kind of becomes second nature to you. So the power that it is taken to, so let's say, for example, it is 6x to the 5th. That 5 is going to come out front. It's going to join the 6. So you'll actually end up multiplying 5 times 6. And then you're going to take your variable to a power 1 less than 5, which is 4. You can do it with negative powers, you can do it with fraction powers, you can do it with whole number powers, but it's all the same rule. Power comes out front, and then you drop the x to a power 1 less. Our third rule, we actually kind of do it naturally, is called the constant multiple rule. Sometimes it's called the scalar rule. And what it says is if you have a coefficient in front of function, that coefficient basically just stays there when I derive. So we just did one with that when you had a 3 in front of a function, so like x to the 7th. When you derive it and that power comes in front, that 3 is still there. So you'll have to just multiply them together. So you'll do, so this is a really messy 7. So you're going to do 7 out front. So 7 times 3 is 21, and then power 1 less. So we call it a constant multiple, or a lot of times you'll hear it referred to as a scalar or a coefficient rule. We're also going to see it show up with trig, where if you're driving, basically the coefficient just stays right there. 4 is also one that usually comes pretty natural to students. It's called the sum and difference rule. And what the sum and difference rule says is if two functions are being added or subtracted, or more than two functions are being added or subtracted, or a little bit of both, you derive term by term. So, and this is true for any addition or any subtraction. It is a term by term deriving. So, for example, if you have something like 7x to the 4th minus 3x squared plus 5x minus 8. So you have this big polynomial that has all these terms that are being either added or subtracted. When I go to derive, I am going one term at a time and deriving it individually using our power rules and our coefficients and all of that. So power out front, power 1 less. And then bring the 2 out front, so 2 times 3 is 6, power 1 less. Derivative of 5x is just 5, because when you bring the power out front, power 1 less, you no longer have an x there. You get x to the 0 power. And the derivative of negative 8 is gone. The derivative of that is 0 because it is a constant. So that allows us to do any sort of addition or subtraction. So basically looking at polynomials and deriving them one term at a time. It doesn't work that cleanly with multiplication or division, but we'll enjoy the addition and subtraction being simple. And then finally, we have all sorts of derivatives for trig, but we start with the most basic, and the most basic are sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. And the toughest thing to remember, honestly, is when to put the negatives and when not. So the derivative of sine is positive. The derivative of cosine is negative sine. So for example, if you have something like 7 cosine x, and you're being asked to derive it. The constant multiple rule says the 7 stays put, and then the derivative of cosine is negative sine, so I'm going to put the negative at the very beginning. So you have negative 7 sine of x. So those are your most basic rules, and with these rules, we're going to look at how we derive lots of different functions.